So section 9.3 is on the hyperbola. We've seen hyperbolas before that were transformations of the function y equals 1 over x. So this will give you things like x minus 1 over x plus 2, rational functions where the degree of the numerator or denominator are at most 1. And those types will have asymptotes that are that are horizontal and vertical. The ones that we do in this section will have oblique asymptotes, which means they're neither vertical nor horizontal, but some other angle. So we're going to do hyperbolas with a vertical axis of symmetry and hyperbolas with a horizontal axis of symmetry. There are hyperbolas with axes of symmetry at any angle, but that's a section that we're not going to cover. There is a section in the text if you want to go through that and do the practice for it. If you're not sure how, ask me. But those aren't used very often, and we're really just trying to get the idea of the hyperbola across to you and how to find the asymptotes and how to find the vertices and the foci, etc. So we're just doing these two types in this section. So first of all, we have to know the definition of a hyperbola geometrically. Or actually this is analytically we call it. So you have a focus, you have two foci plural for focus, just like with the ellipse, except now the foci are on the outside they're further away from the center than the vertices A and negative A are. So the vertices, it has two vertices, just like the ellipse. They're at A and minus A. Foci, I'm going to call C and minus C here. Now, I'm kind of temporarily assuming that the center of this hyperbola is at the origin, just to simplify the discussion a little. And the thing about the points on the hyperbola is that if you take this distance d1 from one focus to a point, from one focus to some point on the hyperbola, and then the distance from that point to the other focus, if you subtract those, you get a constant, some given constant for each parabola, or for each hyperbola. Instead of the ellipse, you do the sum of the two. The hyperbola, you do the difference of the two. And you just take the larger one minus the smaller one. So, writing that out, a hyperbola is a set of all points x comma y in the real plane with d1, absolute value of d1 minus d2 equal to a constant positive number. It can't be 0 and it can't be negative because it's absolute values. It can't be 0 because then you're just getting a single point and the foci have to be the same. So the points A and minus A on the hyperbola are called the vertices, which I mentioned before. And then, I mentioned this too. So I'm just writing this out so you have it in your notes. In this course, we will only discuss hyperbolas whose foci and vertices lie on a horizontal line or on a vertical line. It's just for simplicity's sake, because we just want to get the basic idea here. So this is the other type. We have two types of hyperbolas. So the first one, the foci and the vertices in the center are all in a line on the first one here, and that line is horizontal. The second one, the line where all of those points are, the foci, the vertices, and the center, that line is vertical on the second one. So it just looks like this. Okay. looks like the other one sideways.